1.0 Introduction. Perhaps computer is the most powerful and versatile tool created by human beings. In today's scenario, computer plays a major role in almost every aspect of life and influences our lives in one way or the other. Today, you can hardly find any area which is not influenced by computer. The word computer comes from the word compute, which means to calculate. Computer is also meant for calculation, but it is much more than just calculating machine.
Computer is an electronic device which performs three basic tasks, i.e., inputting, processing and outputting. A computer accepts the input through various input devices. After receiving the input data, computer performs different operations required by the user on these input. Finally, computer generates the resultant of the processed data as the output through various output devices. Hence, a computer is a data processing device. This unit will provide details about computers, its origins and also descriptions about computers' different components, their applications and some current hardware platforms of computer. Since computer is vastly used for making calculations or controlling operations that are expressible in numerical or logical terminology, yet the development of computer started from abacus and its journey of development is still going on. This unit also focuses on major development during different periods.
1.2 Origin of computers. Origin of computer could be rigorous efforts of men to count large numbers. This process of counting of large numbers generated various systems of numeration like Babylonian system of numeration, Greek system of numeration, Roman system of numeration and Indian system of numeration. Out of these, the Indian system of numeration has been accepted universally. It is the basis of modern decimal system of numeration 0 to 9. 1.2.1 Abacus. Nearly 5,000 years ago, the abacus was developed in China in 3000 BC. The word abacus means calculating board. The abacus may be considered the first computer and it has been used since ancient times by a number of civilizations for basic arithmetical calculations. A modern form of abacus is given in figure. The abacus is also called a counting frame, which is a calculating tool for performing arithmetic operations. The Chinese abacus has a frame holding vertical wires, with 7 beads on each wire. A horizontal divider separates the top 2 beads from the bottom 5, sometimes referred to as the heaven and the earth beads. The arithmetic calculations are performed by manipulating the beads by using the principle of positional weight of beads on a rack. Abacus is used even today to teach small children how to count. A skilled abacus operation can be as fast as a handheld calculator.
1.2.2 Napier's bones. John Napier was a mathematician who became famous for his invention of logarithms. The use of logs enabled him to reduce any multiplication problem. John Napier built a mechanical device for the purpose of multiplication in 1617 AD. The device was known as Napier's bones. His bones are set of 11 rods side by side. Products and quotients of large numbers can be obtained. The sticks were called bones because they were made of bone of ivory. 1.2.3 Slide rule. English mathematician E. Gunter developed the slide rule. This machine could perform operations like addition, subtraction, multiplication, and division. Although the slide rule appeared in various forms during the 17th century, it consists of 2 movable rulers placed side by side. Each ruler is marked off in such a way that the actual distances from the beginning of the ruler are proportional to the logarithms of the numbers printed on the ruler. By sliding the rulers, one can quickly multiply and divide. 1.2.4 Pascal's calculator. Blaise Pascal was a French mathematician and one of the first modern scientists to develop and build calculator. He developed a machine at the age of 19 that was capable of adding and subtracting numbers. The machine was operated by dialing a series of wheels, gears and cylinders. 1.2.5 Gottfried Wilhelm Leibniz, a German mathematician, philosopher, and polymath, designed a mechanical device known as the Leibniz's multiplication and dividing machine, also referred to as the stepped reckoner, in the late 17th century. This innovative machine was designed to perform basic arithmetic operations, particularly multiplication and division, automatically and more efficiently than manual calculations. Leibniz developed the concept of the machine in the early 1670s. And the first practical version was completed in 1694. The main idea behind the Leibniz's multiplication and dividing machine was based on the step-by-step principle of performing arithmetic operations. It utilized a series of step drums or cylinders, each with 9 teeth on their periphery. Each drum represented a digit from 0 to 9, and they were arranged in such a way that when rotated, the teeth would interact with other mechanisms to carry out multiplication and division.
1.2.6 Difference Engine. The first step towards the creation of computers was made by an English mathematics professor, Charles Babbage. Early on, he realized that all mathematical calculations can be broken up into simple operations, which are then constantly repeated, and that these operations could be carried out by an automatic machine. In the 1820s, Charles Babbage started working on a difference engine, but after 10 years, he abandoned it for the analytical engine, the real predecessor of the computer. Babbage outlined the basic elements of a modern general-purpose computer, which was based on the method of finite differences. It uses only arithmetical addition and removes the need for multiplication and division, which are more difficult to implement mechanically. Charles Babbage is called the father of the computer. 1.2.7 The Analytical Engine. The analytical engine marks the progression from the arithmetic calculation to general-purpose computation. It was also developed by Charles Babbage. This machine was based on the principle that, for certain formulas, the difference between certain values is constant. The analytical engine has many essential features found in the modern digital computer. The engine had a store, memory, where numbers and intermediate results could be held, and a separate mill, processor, where the arithmetic processing was performed. It had an internal stock of the 4 arithmetical functions and could perform direct multiplication and division. It was also capable of functions like conditional branching, looping, iteration, microprogramming, parallel processing, latching, and polling, etc. The logical structure of the analytical engine was essentially the same as that which has dominated computer design in the electronic era.
1.2.8 Mechanical and Electrical Calculator. In the beginning of 19th century, the mechanical calculator was developed to perform all sorts of mathematical calculations. Up to the 1960s, it was widely used. Later, the rotating part of mechanical calculator was replaced by electric motor, so it was called the electrical calculator. 1.2.9 Modern Electronic Calculator. The electronic calculator used in 1960s was run with electron tubes, which was quite bulky. Later, it was replaced with transistors, and as a result, the size of calculators became fairly small. The modern electronic calculator can compute all kinds of mathematical computations and mathematical functions. It can also be used to store some data permanently. Some calculators have inbuilt programs to perform some complicated calculations. Modern electronic calculators contain a keyboard with buttons for digits and arithmetical operations. These calculators can perform sophisticated arithmetic and financial computations, such as converting from polar to rectangular coordinates, taking square roots, computing logarithms, and trigonometric relationships.